Okay, good morning. Welcome to
FamilyMath811.
So we're continuing on with a little short project today on Mathologger's video about what? Well, what was his video about?
Well, his video is about proofs that different square roots were irrational. Like he proved the square root of 2, the square root of 3, the square root of 5, and the square root of 6.
Okay, and so what is we've made one of this shape out of our Zumthor set. What is this shape?
This is the proof that the square root of 5 is irrational.
Okay, can you sketch what's going on here?
So what you did here is you've got this huge 9x9 pentagon, and then you have these smaller 4x4 pentagons with side 9, pentagons with side 4, and then you've put one pentagon in each of the vertices and folded them in. Now you've said that 9 and 4 previously are the smallest numbers that can satisfy this, that 5 4x4 pentagons is going to fill up a 9x9 pentagon.
Okay.
But then as you do this, you get a surprise that you've got a 2x2 pentagon here, and then 5 1x1 pentagons around it. And you can repeat this. You can repeat what you just did.
Okay.
So what you do is you have these little kite shapes. So if you connected this vertex here.
Can you throw him the pentagon that you have next to you and show that makes a pentagon there?
That makes a pentagon, and then this is actually empty space because the pentagons are going like across like that.
Okay.
So this is empty space, but this is an overlap because now you have 2 pentagons in this area. So you take this and use it to fill the empty space.
Okay.
And then you take off, the pentagons are also overlapped, so you have 5 more spare 1x1.
This is empty space in the middle.
And then you just do the same thing over and over again.
I see. So if the 5 4x4 by 4x4 pentagons filled the 9 side, the pentagon with side 9, then 5 1x1s would fill what?
Would fill this 2x2.
Would fill the 2x2 pentagon. Or the pentagon with side length 2 might be a better way to say it. Okay, but we had said that 9 and 4 was the smallest one, and we produced a smaller one. And that smaller one has integer sides.
And then you'll be able to produce a smaller one from this.
Interesting. Okay, so yeah, that's a sketch of the proof. Mathologger asked a few questions. One of the questions he asked is, his approach to showing that the square root of 5 was irrational was to show that you had two numbers x and y, such that 5x squared, or x squared plus x squared plus x squared plus x squared plus x squared equals y squared. Here our example was 4 and 9. Well, first of all, does that work? Is 5 times 4 squared equal to 9 squared?
So
not exactly. 5 times 4 squared is 80, and then 9 squared is 81. So that's close.
Call that like a near miss.
Right, he called that a near miss. Okay, but with his triangles, he actually had squares when he was doing the square root of 3 proof, and in the square root of 2 proof, he did it actually with squares.
Yeah.
Right. So one of the questions he asked here is, where are the squares? Where is our x squared and y squareds here?
So they must have something to do with the pentagons. Since we're saying that 5x squared equals y squared, we're trying to disprove that statement.
Okay.
So we have to, the squares somehow have to be hidden in the pentagons.
So.
But how are they hidden in the pentagons like this?
So it means one pentagon has to be 1x squared. One of these, one with side length 4.
The one with side length 4 has to be the x squared. Yeah.
And then the large one has to be the y squared.
Yeah. So the one with side length 9 is the y squared.
So can we like rearrange this pentagon to form a square?
Well, that's an intriguing question. Where are the squares? So with the triangles, he was able to show you, with his triangular squares, he was able to show that he had a perfect square number of triangles. But it's not clear what there's a perfect square number of here.
Well, you might. I was thinking you might use the 7th one pentagons, but it's kind of hard to fit them in a larger pentagon because you don't get this angle. You get this angle here. You can't fit in all.
They don't tile very well.
Right, the pentagons don't tile. Right, that's exactly the problem. So it's an intriguing little puzzle. So you're still puzzled by that?
Yeah.
Okay, well, we'll keep puzzling on that. I want to go to one more thing and then, so one video here with the picture and then we'll go to the computer, okay?